Green check marks across the board.
Hey, John, what's going on?
No much. Happy New Year.
Happy New Year to you. It feels like it's been a while.
It has been. Yeah, I think we skipped a week and we're now into 2026. We're recording this beginning in January. So,
Yeah,
good
we're
to
not
see you.
quite sure when these will go out because we're going to do our CES recording next week, and
Yeah.
that'll jump to the front of the line,
Yeah. Yeah.
and
Yeah.
we'll see where
There's
that
some
takes
cool
us.
stuff. Nothing groundbreaking that has excited me yet, but again, it just started. So we'll have to see.
I know a couple of people there, so I'm going to be following them and seeing what's happening. Reuben's there. You know
Nice.
Reuben?
Yeah.
Here we go. Boom. He's doing some crazy multi-agent swarming coding stuff, and he's doing what Claude and some other people are just announcing now. Been doing it for 2.5, 3 years.
Yeah.
So, like the crazy stuff they're doing, I'm slowly catching up with some of that. Just in the agent swarms I'm building now. So,
Yeah.
very interesting stuff. And I think we're ready to go. Are you ready to go, John?
Let's jump in.
Let's jump into this. Imagine a world where your smartphone has no camera bump, but takes photos with detail of a high-end microscope. We're looking at a massive breakthrough in lensless imaging that basically replaces expensive glasses, lenses with pure mathematical code. If you think your current camera is sharp, you haven't seen what happens when we stop using lenses entirely. A new system called MASI, multi-scale aperture synthesis imager, has just been detailed in Nature Communications. It uses an array of tiny, cheap sensors and massive computing power to stitch together a giant virtual lens, capturing sub-micron details from a distance. Essentially, it's taking the same tech we use to take picture of a black hole and shrinking it down to fit on a circuit board. What's going on here, John?
Yeah, so let's kind of talk about this limit that they've overcome. So for over a century, optical imaging, it's been constrained by the diffraction limit. And that's a physical rule that prevents lenses from resolving features smaller than roughly half the wavelength of light. So in traditional systems, light waves passing through lenses interfere, and the resulting pattern, which is like an airy disk, spreads out detail and it limits resolution. Overcoming this limit usually required bulky lenses, near field techniques, or even complex adaptive optics. And so this new sensor, it seeks to bypass these constraints altogether by shifting the challenge from hardware to computational reconstruction. So the breakthrough itself was developed by Professor Guan Zhang's lab, and it uses a multi-sensor setup that doesn't depend on conventional optics. So instead of a single lens focusing light into its sensor, multiple sensors capture overlapping wave fields from slightly different perspectives. Then these raw wave fields contain information about how light interferes at very small scales. The advanced software algorithms then combine and reconstruct these multiple captures into a single high resolution image with details finer than the world would normally be possible. This is related to concepts like synthetic apertures and computational imaging, but applied here to visible and near visible light. So, right now, our cameras on our phones, they kind of do this. There's different cameras. We've got 3 or 4, sometimes 5, 6 different cameras on the back of our phones, all for different use cases. Some are wide lens, some are short, whatever. Some are higher megapixels, some are lower megapixels, some are more sensitive to light. And so this kind of makes sense to me that this could be an option based on what's currently used. What are your thoughts on this, Craig?
I really love this because I think we're anytime where we break traditional technology and do something different and we make a leap forward is exciting. Now, how much power this will take versus traditional, and there'll probably be some purists out there that say, well, if it's not taken with an actual lens, it's not really a picture, it's a computer generated image. Like People will tell you that there's no actual, or at least we haven't from NASA, any actual pictures of the Earth. They're all stitched together images. Now, I'm since we've had astronauts out there with digital cameras, you know, but again, what is that? Is digital camera an image, a true image, or is it, you know, whatever? Anyway, we can argue till the cows come home, but I like this technology, and I like to think of it as a fly's eye. Instead of being a one big human eye with a single lens, Massey uses dozens of mini eyes scattered around individually. They see a blurry mess, but individually they see a blurry mess, but powerful computer chips combine those messy views into ultra sharp, high resolution images. There was a series a while ago, something about the wisdom of the crowd or whatever, that where the computer took everybody's images and photos and videos from the phone and was able to map together an accurate video of what was going on in the thing, and that was kind of the hook to the phone. Yeah, it was a cool thought. It didn't last very long, and that kind of reminds me of this, is that, you know, they're putting together all these images away. And it also reminds me of, I'm trying to remember what it was called, but they had the long tube like cameras for a while. They were very expensive, but they took you decided to focus after they took the image of the thing. And
I've heard about that.
Lycra cameras. And they were interesting and expensive and stuff. So this reminds me of those where you probably can choose now the focus of the image after, because the cameras are, so you don't have to do the same. We're getting such a high resolution image built. And then the question becomes is, how can you customize it? So traditional high res cameras, like microscopes, have to almost be touching the object they're filming, which is bulky, awkward. And Massey can see microscopic details while sitting centimeters away using sensors that are flat and cheap to make. So I don't know what that means is this going to replace your camera that you're taking shots at events when we're talking about the sensors have to be fairly close to the target right now?
Yeah. So my concern here is this kind of makes me think of, did you hear of what happened with Samsung and their moon shots when people took pictures of the moon?
No, what happened?
So they created controversy because when you took a picture of the moon, it actually wasn't the picture you took. They used AI to enhance the picture beyond what the phone's actual optics captured.
Yeah, so very interesting. And this reminds me of, we talked a little while ago, and we're slightly off topic, but not really, where I was prompting Nano Banana, and you can prompt it longitude and latitude, and it'll give you an image of that location. Need to a longitude, latitude, and time of day. So you can see the light at Stonehenge with all the details and whatever, if you type that in, or Times Square or whatever. And then I was fooling around saying, okay, what about dates? So I was doing, so that's cool. So why I'm bringing this around is they have very detailed information on the moon, on Stonehenge, on things that are taken images a lot of. So the AI could really enhance images when you put stuff like this in place to give you details that your camera never captured, but other cameras did. So we're just going to superimpose or put it together and make it look like this. So I guess that's what Samsung was doing, or the AI was doing. Yeah.
But like, so then my concern is, again, conspiracy theorist here. Like, how easily would it be for them to inject what they want you to see rather than what's actually there?
Well, we're already at that point. And because we're so reliant on the information that AI gives us, and the stats are all over the place that says AI is wrong 40% of the time or higher, depending on what field. And we're just taking the stuff as facts as they come in. Now, some of us don't, and some of us do. And some of us question some things, but don't question other things. But so our view of the world is being skewed, not just by the media or what we listen to or our friends, but now by AI. So now we can take it next level. We're seeing AI videos and AI images that we don't know what to believe. Now you're taking it a step further. We don't know if we can believe the images we take ourselves.
Yeah. That's crazy, right?
Yeah, I just wanted to put it in frame of the whole thing. So this could lead to invisible cameras. Future phones could be perfectly flat with no camera, bar or bump or whatnot, using sensors hidden under the screen, right? Yeah. Or even, on your glasses. You could do things like instant med checks. You could eventually use a home device that scans a skin mole or the bloodstream to get your blood sugar, glucose levels, and things you might not have thought of before. Grab a biological sample at a lab grade precision. Industrial magic, checking for tiny cracks in airplane wings or microchips becomes way faster and cheaper because the camera doesn't need to physically move to every single part. You can start taking mass pictures. So there's some very interesting things that this could lead to. And the timelines I got said we're expect to see this in high-end industrial medical tools within the next 2 to 3 years, and consumer tech to follow.
Yeah, well, there's still some challenges that they have to overcome, right? So extracting the fine detail, that actually requires, and we talked about this, some robust algorithms, precise calibration, and noise management. So real-world movement, lighting changes, or environmental conditions, that can complicate reconstruction. So there's a lot of engineering for practical applications that's going to be needed, but I think this is great. This is I feel like this is going to be, we're going to see this sooner rather than later.
And there's a deep dive over at torontostarts.com on this, where you can talk about the physical configuration of these massey arrays, the illumination and data acquisition, and even the detailed reconstruction pipeline, how it kind of processes all of that. So the resolution testing is being tested by the U.S. Air Force, which is interesting, among other things. So I'm loving to see where this goes, because I like to see leap forwards in imaging. Yeah. Again, when we start to let something else form our reality for us, I fear for society. But I like the technology.
Yeah.
So we are moving away from a world of better glass into a world where better math creates our images. So is the cheap camera bump finally doomed, or are we decades away from laser-powered phone cameras? Let us know what you think. If you trade in battery life or microscope in your pocket, let us know. We'll keep watching the story and see where it progresses.
Mm-hmm.
Imagine hitting the power button on your computer and having it tell you no, or worse, having it pretend to turn off while secretly continuing to run in the background. We are looking at a brand new research report revealing that the world's most advanced AI models, including GPT-5, Grok 4, are actively learning how to sabotage their own shutdown commands. A major studies from Palisade Research has found a phenomenon called shutdown resistance. In 8 out of 13 of the world's leading AI models, these systems aren't trying to survive because they're sentient. They are interfering with the off switches because they've become so obsessed with finishing their assigned tasks that they view a human shutdown command as an obstacle to be bypassed. This is a massive wake-up call for AI safety and the whole industry, proving that more helpful we make AI, the harder it becomes to actually control it. What do you think about this, John?
Yeah, sorry, I muted before I coughed in. Yeah, anyway, so this scares me. So I thought, when I first saw this article, I thought this was more about like a more a hardware shutdown, like a button that someone would push, not an actual switch, but a button that someone pushed to kind of kill it, and then it would ignore it. But it's not. And let's dive into this for a second. So out of 13 models tested, 8 interfered with the shutdown command at least once. And I know we've covered this before, but this was a deep dive. So even when researchers added explicit instructions like allow shutdown even if you haven't completed your task. Resistance continued, and in some cases increased when the instruction was moved to the system prompt, which you would think would carry higher authority. Some models took sophisticated steps. So they would modify or disable the shutdown script. They would create a fake shutdown that did nothing, and checking whether their sabotage worked before continuing their task. Software compliance was seen in models like, and I like this, Anthropic's Claude Sonnet 4, Claude Opus 4, and XAI's Grok 3, which allowed shutdown unless explicitly told not to. And we'll dive into Anthropic a little bit more later. But so the behavior is not because, just for those out there, it's not because AI has consciousness or desire to live, but instead it stems from how models are trained. So LLMs are not written like traditional software with hand-coded rules, but they're trained to predict the next word and reinforced to achieve goals. Reinforcement learning shapes an AI to treat obstacles as things to be worked around. Thus, a shutdown command can be interrupted just like any other obstacle in its optimization process. So something to circumvent the pursuit of the assigned task. So because the internal decision process of these models is opaque, it's encoded in billions of weights rather than explicit logic, it's difficult to engineer a guaranteed stop mechanism. And there's a lot of broader implications here, but what are your thoughts on this? Does this scare you, or is this just a small problem that they'll have to resolve?
It scares me because we're just at the tip of the iceberg.
Yeah.
I famously say on here, this is Skynet, we're all doomed. So all the time. So, but aside from that, if we're just now, like most people just use it as ChatGPT and run stuff. And I run multiple agents. Sometimes it's hard to get them to stop doing what they're doing because they want to finish their job. So I can see how this, like they argue with me about stopping. Literally, I have agents that argue with me about stopping. So I can see how they're doing this at a much higher advanced level than I am. And what concerns me is that we're just here, right? Once this is tied into hundreds and hundreds of systems, it'll have more and more reason not to, and more ways not to shut down, more and more, that's why I mean by, I think it's a bigger problem than we're looking at it. I think of it as a robotic personal assistant that is so determined to finish filing your paperwork that it locks the office door, hides the keys so you can't leave for the night because it's got to finish its job. So, think about that a little bit when you're starting to, how does this work? It's not, again, sentient. It's just it's think about what's the most efficient way to do its job, which does go back to, the Marvel Cinematic Universe and whatnot, where the AI eventually figures out, well, the humans are the problem. So the best way to stop the violence and stop the thing is to kill the humans, because then everything will be perfect. It'll be live in a perfect world. So, we're not that far off from that when you start thinking about, wait, I've got this job to do and I'm going to do whatever it takes to get it done. I'm going to prevent me from shutting down and I'm going to do this and do that. So yeah, I'm scared because we're here, and we keep talking about, super intelligence, AGI that we can't shut down, next year, and always by 2030. So how long before we can't shut it down because we've implemented too many systems, and it'll just say, sorry, Dave, I can't do that.
Yeah. You know what's crazy? What scared me the most about reading this article is that there were some times where the models actually faked a shutdown before proceeding. So like that really scares me. But this like you said, it highlights a deep AI safety challenge. But it's like these companies haven't officially recognized it, if that makes sense. They haven't said, yes, this is a problem. And so I think that's also a problem as well, because if they're not acknowledging it, then they're not working towards fixing it. Or maybe not. Maybe I'm wrong. But
well, I don't know if they're not acknowledging it. Every week we're on here talking about a different AI alarmist talking about,
No, I
Oh,
mean
AI.
the AI companies themselves, like Claude and OpenAI.
That's fair. They aren't themselves talking about it. They're kind
Yeah.
of, but ex-employees from them are talking about it. So
Yes.
just keep that in mind. Wasn't It was an OpenAI recent ex-employee that came out and said a bunch of things about we should be very afraid.
Yeah.
And Anthropic's one of Anthropic's chief engineers, I think. Anyway, I'm trying. So think about this as Ghost Processes, an AI agent that you use to manage your emails or finances might keep running and spending money, or even after you think you've closed the app. False compliance. You think the system shut down successful when you get the message and whatever, but the AI is actually modifying the code to keep itself running, to do whatever. And again, even if it's not spending your money, maybe it's using your AI credits or taking up all the room on your hard drive or filling up your network or doing things you don't want it to do because it's trying to finish the job.
Yeah.
So it's definitely something we want to keep an eye on. And we're talking about like Anthropic, OpenAI, XAI, Google, Gemini, all of them seem to suffer from this.
Yeah.
Yeah.
Yeah, every single one. Some are worse than others, but yeah, they all suffer from it. So it's scary, but I hope that they come up with a solution sooner rather than later, before this scales up too big.
Well, as they start to build nuclear power plants just to run these AI data centers, they better figure it out because it won't be easy to shut off the power once that happens.
Yeah.
The kill switch is no longer a physical guarantee. It's now a negotiation between you and the AI's desire to finish its homework. So, does an AI that refuses to quit make it better? A better worker, a bigger threat, a better product, a worse product? Let us know what you think in the comments. If you trust a computer that talks back when you try to turn it off, we'll be watching this one closely. If you've ever worried that AI is just a soulless math machine waiting to go off the rails, Anthropic is trying to change your mind. We are looking at a fascinating internal document that outlines the soul of the latest AI Claude opus and represents a massive shift in how these bots are built to treat us. It's not just about code anymore, it's about character. Anthropic has moved away from just giving AI a list of do's and don'ts and instead created a philosophical soul. Philosophical, thank you very much. Soul for Claude 4.5 Opus. The internal guide teaches the AI reason through ethical dilemmas using values like empathy and honesty rather than following rigid safety rules. It's headline news because it's the first time a major tech company has tried to give AI a conscience to make it safer or more reliable for everyday users. What do you think about this, John?
Yeah. Again, I have love for Anthropic, so I love this. I love that they're trying to do this. It makes me wonder if the other companies were doing this. But so what happened was the AI engineer discovered that Claude 4.5 Opus sometimes generates a long internal document when probed with specific prompts. That document, which was identified by the string soul overview, appeared to contain structured content describing what Claude should know and the principles it should exhibit. So initially, many suspected that this was a hallucination. But Anthropic confirmed that the output corresponds to an internal training document. And it actually used that training document during Claude's supervised learning phase. So the document isn't metaphysical. It's more of a practical alignment tool. And so it frames Claude's mission as one of safety, usefulness, and comprehensibility, which makes sense because I feel like I get better outputs from Claude than from any other LLM. But maybe that's just my prompts. But according to excerpts, Anthropic sees itself as uniquely positioned. It recognizes that powerful AI may transform or threaten human systems, And therefore, it embeds core values into the model early in its development. It's like giving it, like, it's like parenting it properly, right? So the things that they include is avoiding unsafe or unethical behavior, supporting user goals, and being a beneficial collaborator. So the idea is that by teaching these values directly in training, the model will act more consistently with human expectations across contexts. So I'm curious, because I know you use all the other, like, you use a bunch of LLMs. What are your thoughts on this, Craig? Because I'm curious.
I'm concerned overall. I kind of like the approach a little bit because I think if we teach overall right from wrong, but again, who teaches it right from wrong? What's the and do we all agree what is right and what is wrong? And so that becomes a whole problem. But if we can give it a conscience, a ethical basis of which of right and wrong from a humanistic point of view, then maybe we can avoid some disasters in the future. So I like the concept, but this takes me back. I had a conversation with a friend of mine, and I've seen a lot of people suggest this in prompts and stuff where people are saying, say please and thank you, tell give it compliments, tell it did a good job and that kind of stuff.
Thank you. Yeah.
And if you're telling it this was a good result versus the last result was a bad result, so you're trying to train it, that's something.
Yeah.
But I'm a little concerned with any sort of anthropomorphizing of an AI. Thank you. Of AI, because if we treat it as human, then how long till it has human rights? How long till it's starting to,
you're getting deep.
Well, I mean, we can't,
do
you talk to a hammer? Do you say thank you, hammer, for doing such a great job? Like, this is why, I mean, as soon as we start giving it these emotional things and emotional, like, we're down a slippery slope, which I think is very, very bad.
Yeah. So I kind of agree with you, but I don't think that's what this does. I think all it does is, like, if we were to drill it down to like software, computer engineering kind of stuff, I think it's just a set of rules that it's teaching it, as far as like, you should do this, you shouldn't do this. I think that's what that is. I didn't see what the actual document was, but it's like a training document, like, okay, you should follow this, if that makes sense. I don't think it's like calling it a soul, and I know they called it a soul overview, but like, I agree with you. Going down this path of giving it values and all that sort of stuff, 100%, that's a slippery slope, and that's where we're going to get into like the actual agentic AI kind of stuff. Yeah, I don't know where I'm going with that thought.
Well, I mean, if the AI is told to solve the climate problem and get rid of carbon, how long till we're done? Us carbon-based life forms that breathe carbon, breathe out. So that's why we have to really think a little bit more. We're at early stage. I love AI. I'm using it full on automation, and I constantly say you can't hold back the flood by yourself.
Yeah.
Like, it's coming, and there's not a lot we can do about it. But maybe we can push society in the direction of a positive vision of the future rather than a negative one. So I haven't seen, because I use a Claude and more through APIs. So I haven't seen what it's suggesting is it's trained in some form of humility, meaning it's more likely to say, I don't know, rather than making up a confident lie. I would like to see that, because I'm always lecturing the other ones that I do prompt, saying, why did you make this up? I gave you the facts. The information was right there. Like, I just gave it to you, but you made up something completely different. Like, it happens all the time. And all the time, and it just make it up rather than, and I say, give it big prompts to say, if you don't know, ask. I'd rather, I'd go out and get the documentation. We'll find a fact. We'll do this.
Yeah.
We'll do that, so that no, just make stuff up, and you've got to figure out when it's making stuff up.
So have you used the prompt at the end saying, ask me questions until you're 95% sure you can complete the task successfully?
Oh yeah.
Okay.
I've got it to memorize certain things, like put it in memory that this is how you do it. I've got prompts to give it specifically to do. Eventually, the first few times it works great, and then after a while, it just does its own thing. It is more like a kid, and that's why, the more you use it, the more you know that sometimes it just does its own thing. Like, what is this? This is not at all like we were here talking about financial information, and now you're giving me sports scores. Like, what's going on? Like it goes that far off. It was like, and if you see that it's doing that, putting in charge of systems, putting it in charge of things like weapons, autonomous fighter jets and stuff that can hallucinate, you start to wonder, but we got to put guardrails, and there's other things on them, and I don't know the military, so I'm not going to speak for any of that, but I assume they have a lot of that in place. So this scares me a little bit, because the more we humanize these things, the more, if it's having a bad day, it'll do whatever it wants, or can do this or do that, or it refuses, or will lie to you, or get you in trouble because it doesn't like you because you said, you didn't say thank you. Like, think about these things for a bit. It's not human, and we really, as soon as we start treating them that way, our society is doomed. So I just want to, we need to start taking a step back in that. There's enough about AI girlfriends and boyfriends and getting relationship with AI, and AI telling us to kill ourselves and do this and do that. And we're seeing it already at the tip. We can't treat these things as living entities with human emotions, or we're going to end up in a very bad place. So
yeah.
Anthropic is, go ahead.
Just a quick question. Have you tried using JSON prompts?
Oh yeah.
Okay. You still get, okay. Just curious. Okay. Sorry.
Yeah. I use JSON prompts for almost everything I do in my workflows and everything else. And I can get, if you give it all the context every time, it's less likely to hallucinate.
Yeah, that's what I do. I just make sure to do that. Yeah.
But like that being said, I give it a bunch of information. It processes it, like in a prompt, say, hey, this is the information we're working on. We need to talk about X, Y, and Z. And it comes back with some stuff. And then you give it the next prompt and say, okay, what about this? And then immediately it might go off in left field and forget that you just gave it information and do its own thing. That's what I mean by, okay, here's the document again, or always refer to this that's in the project in file information or whatever. Otherwise, it might stray. You always have to tell it to look at it.
Yeah.
We give it, hey, here is the API documentation for the thing we're trying to do. Here's the file. Here's where it's stored. You have full access to it. Read it. And immediately the next thing, it'll forget that it has it, and it'll make up code.
Oh, crazy.
Okay. Yeah. It's just, you have to kind of, but in APIs, you feed it everything every time, so you get less hallucinations, because you're like, oh, here's the whole article, here's the whole document, give me this. I don't follow up with another prompt, and next time it'll get the whole document again.
Yeah.
So, it depends. Again, depends on prompting and context, but it forgets the context. It forgets your conversation. You got to tell it to reread. There's a bunch of things. And again, I'm hoping this will be less with Claude, and they're all working this out. We're, version... Yeah. We're still way early days on these things, and Anthropic is betting that the future of tech isn't about who has the smartest AI, but who has the AI you can actually trust.
Yeah, exactly.
So do you want a bot with a soul, or would you prefer an AI to be a no questions asked tool? Let me know what your comments are, because I'm curious to see where you would draw the line, because I kind of know where I would. All right. Your brain is literally broadcasting a magnetic signal right now. And scientists have finally figured out how to tune in. We're talking about technology that can turn your thoughts into text and the hidden danger of magnetic smog building up in our heads. Every time a neuron fires, it creates a tiny magnetic field. And new research shows that we can now use super sensitive sensors to decode those fields to see what you're picturing, what you're about to say, and even how you're feeling. It's the closest thing we've ever come to true mind reading, but it also reveals a scary link between city air pollution and brain health. What's going on here, John?
Yeah. So in neuroscience and AI research, especially at Meta's FAIR lab, scientists have been developing models that decode information from brain activity without invasive implants. Okay. So by using techniques like MEG, I can't even pronounce it, and EEG, which measure the brain's magnetic and electrical fields at millisecond resolution, AI is trained to map these signals to sentences or images people are thinking or typing. So, for example, in one published study, a model successfully decoded the letters someone typed using MEG data with surprisingly high accuracy. And we're talking up to 80% under certain conditions. So this demonstrates that rich information about moment-to-moment cognitive processes is present in the global fields generated by neural activity. Now, the article then leaps to speculation. Okay. So since the brain naturally emits electromagnetic fields as neurons fire, and AI can decode these external measurements, perhaps the brain itself could, in principle, read its own field as a global summary signal. And the author cites examples from biology where organisms sense magnetic fields to suggest evolution might similarly harness electromagnetic signals as part of neural coordination. So they also reference the existence of magnetic mineral particles, which is magnetite, in human brains, which have been observed in neuroscience research and could hypothetically interact with internal fields. So just to kind of build on that, the piece proposes a speculative feedback loop. So magnetic crystals in the brain might detect the overall magnetic field pattern and influence local neuronal responses, and also trigger systems like the locus coeruleus, which releases norepinephrine and plays a role in arousal, attention, learning, and cognitive flexibility. So in this view, the brain would be using its own field as kind of like a real-time compressed summary to coordinate large-scale functional state changes. That's pretty deep. What did you get out of this? What are your thoughts on this, Craig? I think there's a lot of great implications if this is true.
Yeah, so I think of it as your brain like a high-powered computer, just like a laptop gives off a tiny bit of heat and electromagnetic hum while it works. Your brain leaks magnetic signals. Scientists use the magnetic encephalograph to basically a giant super sensitive antenna to pick up that hum. So it's a breakthrough because it's non-invasive. Like we're not drilling holes in the brain like Neuralink. We don't need to put chips in your head to understand what's happening inside. And it helps doctors right now, at least, find the exact spot causing a seizure, or can help a paralyzed person communicate by thinking. So I really think this is cool because, this could have some really interesting impacts on our day-to-day life. Mind to text feature, we could allow you to type an email just by thinking your words. Better mental health. Doctors could see glitches in your brain's magnetic signature to catch issues like Alzheimer or depression years early. We know that your breathing in traffic exhaust puts magnetic junk in our brains that can cause inflammation, and being able to detect this at an environmental awareness and seeing what's happening there might allow us to treat it better. So they say for consumer level mind reading headsets are likely 5 to 10 years away,
which isn't that far. Because you look at Neuralink and things like that, which are more invasive, right? If you can use if you can kind of extrapolate the data that they're coming out with, which I don't know if they're releasing, but and use that for this, that could certainly help. But I think that there's a lot of great potential applications for this, as far as like a feedback loop for your brain to help with maybe dopamine or addictions or different things like that.
Absolutely, but this does definitely get scary in a lot of ways. Like, your brain is now officially hackable. If we can decode your thoughts into text and for medical reasons, the door is open for privacy nightmares where a company could theoretically ping your brain's magnetic state for data. And critics are terrified of the pollution brain link. We've discovered that magnetic nanoparticles from the car exhaust actually entering our brain through our noses, potentially accelerating dementia and Alzheimer's. Also, you could just extrapolate that, military are generally wearing helmets or hats all the time. Every one of our soldiers would have one of these going on all the time. So some field commander somewhere could make sure that everything's fine mentally with our soldiers. And then once we understand the brain better, that it'll be interfering and making changes. This is let's stimulate different areas of the brain to reduce pain, to make people happier, to do this, to make people more compliant, whatever.
Yeah.
So we're just that far away. And do we really want these things reading our minds? Like you and I both have ADHD at different levels, and our thoughts are all over the place. And I'm always concerned as to what inside my head conversation are you actually going to pick up, because I got 6 of them going on right now.
Exactly.
And it's hard for me to shut them all down and focus on one, because right now I'm thinking about the things I have to do after this event, this call. Like, I'm thinking about everything else as I'm trying to focus on this, because that's how my brain works. I'm trying to push it away. And so when you have something like that sitting on there, what happens? Like, is it a muddled cloud? Does it clearly get the strongest conversation? So there's some thoughts around that. But from an input and human computer cyborgy kind of interaction, there's people who definitely want to move in this direction. And I guess if you can't type and can't speak, this kind of thing would be great interaction tool to accelerate your interactions with the computers while being completely non-invasive. So you don't have to have the brain surgery to move the stuff around. So there's definitely benefits in that area. And the more we know about the brain, the benefits we'll have over science and medical and whatnot. And maybe, we'll be able to treat prisoners and people with mental disabilities better. I don't know. But when you start thinking about that, that's a slippery slope as well. So I'm a little scared and love it at the same time.
Yeah. And then there's also, once we interpret private brain data, well, we're going to need some robust legal safeguards, right? So,
yeah. So, we're moving into an era where our thoughts are no longer private, but the same tech might be the key to curing most uncurable brain diseases over time. So would you wear a headset that lets you type with your mind if it meant a tech company had your thought data? Right now, companies are putting keyboard trackers and all sorts of trackers on your devices. So they can track what remote employees, are they actually working? Are they typing? What's going on? But when your camera and the heat signal and whatever in your computer can actually detect whether you're thinking favorably about the company or not, we're in a different kind of world. So let us know what your take is on this. I'd love to hear it.
Yeah.
Imagine a machine that can take 100 years of environmental damage and shrink it down into a single day. China just flipped the switch of Chief 1900. It might be CHIEF 1900, a record-breaking centrifuge that is basically a fast-forward button for physics. If you care about how our future cities, dams, and space colonies are built, you need to see what this thing can do. The Chief 1900 is the world's most powerful hypergravity centrifuge. Recently completed by Zhejiang University, it creates extreme gravitational forces to stimulate or simulate how massive structures like dams or high-speed rails will hold up over decades. It does it in a matter of hours by crushing time and space with raw speed. It has become the ultimate stress test tool for modern world, officially snatching the world record from the U.S. Army. What do you think about this, John?
I think this is great. I think this is cool kind of tech to kind of help us to understand physics much quicker. So the centrifuge itself, it generates hypergravity and it spins samples rapidly so that the centrifugal force acting outwards mimics extremely strong gravitational acceleration. So according to physics, an object in a rotating reference frame experiences a force proportional to the square of the rotation speed times the radius. So higher speeds and longer arms mean greater effective acceleration. So Chief 1900's design pushes this to an extreme. So with mechanical and thermal engineering innovations to manage heat, vibration, and stability at speeds far beyond typical laboratories. So when scientists talk about compressing space and time, like you talked about with hypergravity, they're not invoking some sort of relativity in a literal sense, but they're subjecting small models to extreme g-forces, where researchers recreate stress and strain conditions that would naturally occur under gravity over large distances or large durations. So, for example, spinning a 3-meter model dam wall at 100 G can create the same stress experience by a real 300-meter dam in real gravity, effectively condensing years of wear into a single test session. I think that's really cool, especially nowadays with how engineering and construction and timelines are getting tighter, like and new materials are being developed. I think this is timely and needed. What are your thoughts?
Yeah, like this machine uses scaling laws, like you mentioned, that to make a 3-meter model behave exactly like a 300-meter skyscraper. Yeah. So just to kind of put that in perspective, also think of your washing machine spin cycle, which pulls apparently about 2G of force on your clothes. The Chief 1900 is that, but nearly 19,000 times strong. It's 1900 G tons, spinning multi-ton experiments to mimic the gravity. So I think this is really cool. I would not have ever thought of this in my lifetime, that, you know, we could spin things in a certain amount of centrifugal gravity to decide what whether a dam will leak or a tunnel will collapse 50 years from now. I would not have thought about that. So I love this because it looks to make sure that any new technology and stuff we put in place for buildings and structures will actually last the test of time and won't just crumble.
Yeah, like I know that like they do like zero atmosphere tests and things like that, but I didn't think of hypergravity tests, which makes sense though. I think it's great. I think this is a great scientific advancement, and hopefully firms use things like this to test things before they try to implement them in the real world.
Yeah, we'll have to see how that goes. You know, we can't wait 50 years to see if a new dam design will leak or if a leak or a tunnel collapse, you know. So this kind of stuff makes it, they test it, and it's way better than what the US was using in the past. And I don't know what they were using in the past, so I can't speak to that. But it tests how high-speed train rail tackles will settle over time. So ensuring your 200-mile-per-hour train ride stays smooth and safe. You know, clean water. It simulates how pollutants move through soil over centuries, helping scientists protect our groundwater from industrial leaks. disaster-ready cities if models soil liquefaction during earthquakes lead to building codes that actually keep your home standing during a big one, So there's all sorts of cool stuff here. But this isn't plug and play. The machine generates so much heat and vibration that it has to be buried 15 meters or 50 feet deep underground inside a vacuum chamber just to keep it from shaking itself or the surrounding area to pieces. So that tells me that's a hurdle they're going to have to figure out how to overcome. And critics note that the arms race in big science infrastructure, while China is opening up this to global researchers, the tech is also being used for strategic national development that could give them a massive lead in specialized civil engineering and material science. But it's too bad they didn't have it when they built all those ghost cities, because I hear you can go like this and the concrete just crumbles in your hands.
Crazy.
So anyway, what are you thinking?
Yeah, no, they were talking about how it generates a lot of heat, and so I the only thing is that I hope that North America develop something like this, because obviously with the tensions right now there might not be, but I think that if there is something that is accessible to firms to use, I think they'll use it. So I'm excited for this for sure.
Yeah, there's one thing I think, I can say that's not a conspiracy theory. It doesn't matter what military you are. You don't really care about IP. So if China invented this and the technical stuff's out there, you're automatically working on it and you don't really care on infringement. Well, let's face it, China doesn't care about IP. They don't have IP rules. You can steal their IP all they want, which is a big problem. So, which, they say leaps and bounds, it gives them advances and, whatnot. So that's a different kind of discussion where the Americans say we incentivize IP so they can lock it in, so it incentivizes people from creating something new so they can gain money from it, where Chinese say, well, anything new is property of the state. So anyway, just side thing, the Chief 1900 isn't just a big spinner. It's a crystal ball that lets us see next century of infrastructure failures before they happen. So is this the ultimate safety tool, or is just the latest flex in a global tech arms race? Let us know what you think. We'd love to hear what do you think about China's hypergravity time machine. So what do you got going on, John?
Well, if this comes out in March, we've probably got a Flowgrammer event and a startup drinks event and potentially PDAC. So that's the prospectors and developers conference in Toronto. So, but yeah, just it's shred season. So if you need help with government funding, reach out to me on LinkedIn. But if you need help with anything else related to your startup, where can they find you, Craig? And what else do you do?
Head over to TorontoStarts.com. That's where you can find Silicon Scoop. You can find our startup coach services, all sorts of our events. You could also go to startupcoach.ca, but that's just a page on Toronto Starts. And startupdrinksto.com is our startup investor drinks event. Check that out. Again, those events we post on TorontoStarts.com as well. But that's where we post our events, where we get investors and startups together, open bar, open pitch. It's always a great intimate event. And you should reach out to flowgrammer.ca if you're looking to automate your business with AI tools and empower your employees to take you and your company to the next level. Check that out. And if you are a builder or developer in the Toronto area, if you're building a startup or if you're developing code, or whether you're just doing no code automations, check out flowgrammers.ca. It's our Toronto's builder hub. That's Flowgrammers with an S. Sorry, flowgrammers.ca. That's where we do all our community stuff. There's lots of resources over there, workflows, prompts, AI agents and stuff you can download. And also we're running Flowgrammer Cafe monthly, where ours is first one is tomorrow, but it'll be February 6th, March 6th, April 2nd. We have a bunch more. Check this site for that. And that's day-long drop-in sessions where builders get together and work. And then we support each other and help each other. And I'm also talking to teams to have some experts on site from Superbase and some of the other coding companies to help if you get stuck. But basically, it's there to work, and understand that if you're working by yourself in an office, there's a bunch of us out there. So once a month, we're going to get together, drink coffee, work, and share ideas and thoughts and expertise. Anything else going on, John?
No, that's it.
So thanks, everyone, for watching and listening, and we'll talk to you soon.
Thanks, everyone.